Okay, so our task today is understanding the derivative. Now, if you've checked out my article on understanding things that are difficult, you'll remember that there are a couple of different ways to try to understand really difficult concepts. And one of those ways is by using an analogy. Um, Another way we talk about remembering things and making links is through creating things called mnemonics. So this technique of understanding a derivative is combining something we already know, which is what mnemonics do. We already know about spaceships, with something that we're trying to learn about, which is the derivative. So let's get started. So the derivative is what's the derivative all about? Well, we often see the derivative written in a couple of different ways. The first way we see it written is like that. So that's one way. The other way we might see it written is like this. Dy over dx. This is the second way, and this is the way that we're going to be looking at today. So the first thing I'm going to do is I'm going to tie this to this spaceship to think about dy over dx, which is quite a strange thing to look at. It's, three different letters in two different combinations with a divide sign in between them. What the hell's going on? So we're going to actually link that to a spaceship to try to make it a little bit more concrete, and then we're going to apply that to some graphs and see how that works and see if it helps us, which it hopefully will. So the first question is, if one of these, if the top or the bottom had to be the spaceship, had to be a top or bottom of the spaceship, which one would be which? Well, there's two easy ways to think about this. First off, the spaceships usually face upwards, so the dy relates to the top of the spaceship and the dx relates to the bottom. But the other way that I like to think about this is, well, the front of the spaceship looks more like a Y. That's an upside down Y, right? We've got this pointy bit which looks like it's going into a Y. And the back end of the spaceship, if we were to do a cross section of that, it would probably look something like this. We're looking from this end on, looking this way, and the flames are coming out here, right? And that looks to me quite a bit like an X. So the front relates to the front of the spaceship relates to the Y, and the back of the relationship, or the dy, the back of the relationship relates to the dx. Okay, bear with me on this one. So let's consider how this can be, how we can think about the derivative in this term, in this way. So we can think about the derivative as the spaceship taking off from a point. So say the spaceship wants to take off from this point, We'll say a spaceship wants to take off from here. And the spaceship's going to take off in a direction like this. So the engineers have decided that it's worth giving the spaceship a bit of a slope, and so we can draw our spaceship. Just pretend that's a spaceship. So it's taking off from 0, 0, and it's been pointed in this direction. Well, what dy on dx actually asks us, what it's asking us in this example, is how high is the front of the spaceship. And in this case, the front of the spaceship, at dy, is just 1 high, right? So this can just be 1. And the back of the spaceship, the difference here is also just 1. So that's just 1. And 1 divided by 1 is just 1. Let's consider another example. Say our spaceship's taking off from here again, but the astronauts have decided that we actually want it to be a bit, or the engineers or whoever decides, we actually want it to be a bit steeper this time. We want it to be like this. We want the spaceship to take off in this way, right? Okay, that's great. So the question is now, when we look at dy over dx, how high is the front of the spaceship? Well, it's 2 high. That's 2. So our dy is 2. And how far back is the back of the spaceship? Well, from the front of the spaceship here back of the spaceship. This is just again 1. So this is just 1, right? And then we can say, okay, so what's 2 divided by 1? Equals 2. And one final example, just to get the feel for this. And a point is that the spaceship can actually take off from anywhere. So let's just say the spaceship takes off from 1. And for some strange reason, the engineers have decided that the spaceship's better off launching horizontally. Okay? And the spaceship can be as long as you like. It doesn't matter. But let's just say it's that long. And it's launching horizontally. So when we look at our dy over dx, how high is the front of the spaceship above the back? Well, there's nothing. We can't draw anything here. So this is just 0, isn't it? And then how far is how far back is the back of the spaceship? How far back is the back of this spaceship? Well, in this case, it's just 1. 0 over 1. So 0 over 1 is just 0. So this is how we can link in the idea of using this spaceship with the derivative. The dy relates to how high the front of the spaceship is. The dx relates to how far back the back of the spaceship is. And we can just launch the spaceship from different points, from 0, 0 here, from 0, 0 here, and from 0, 1 here, this point. And we can launch the spaceship at different angles. And we can talk about how the front of the spaceship is related to the back of the spaceship with the derivative. This might seem a bit abstract, but in the next video, we'll tie this in with an actual graph, and it will make more sense.